Section 10.6, we're looking at alternating series. An alternating series is simply a series whose terms alternate from positive to negative. If the series is of the form, the sum from n equals 1 to infinity of negative 1 to the n, a sub n, then substituting n equals 1 and we have negative 1 to the first power gives us a negative first term. Similarly, if the series is of the form n equals 1 to infinity, negative 1 to the n plus 1, a sub n, then when we substitute n equals 1 in, n plus 1 becomes even, 1 plus 1 is 2, and we have negative 1 to an even power, so our first term will be a positive, because a negative to a positive is a positive. When we're looking for convergence or divergence, we have the alternating series test. Now, notice the alternating series test only gives us a condition for convergence. It does not necessarily tell us when a series will diverge, but simply converge. And what it says is the sum from n equals 1 to infinity of an alternating series. So where we have negative 1 to the n a sub n or negative 1 to the n plus 1 a sub n will converge when the limit as n goes to infinity of a sub n is equal to 0 and a sub n plus 1 is less than or equal to a sub n for all n. In other words, we need to pass our divergence test and have a limit going to 0, and we need to be non-increasing. So let's look at an example. We want to determine the convergence or divergence of the following series using the alternating series test. The sum from n equals 1 to infinity of negative 1 to the n times 1 over n. The first thing we need to do is look at the limit as n goes to infinity of a sub n, which our a sub n is 1 over n. Since this limit equals 0, we pass the divergence test. Next, we need to look at whether or not our series is increasing or decreasing. So we want to compare a sub n plus 1, and we want that to be less than or equal to a sub n. So notice, we know that n plus 1 is greater than n. We're trying to build up our 1 over n, our a sub n. Since when a denominator gets larger, a fraction whose numerator is the same stays the same, this implies that 1 over n plus 1 is less than 1 over n. So our sequence that we are adding up together is indeed decreasing or not increasing. So we can say, since both of these conditions are met by the alternating series test, the sum from n equals 1 to infinity of negative 1 to the n times 1 over n, or we could write this as the sum from n equals 1 to infinity of negative 1 to the n over n, converges. This particular series is called the alternating harmonic series, and it's impressive because we know that the harmonic series, where we didn't have this negative 1 to the n, diverged, but in this case, when we are alternating sign, we actually get convergence.